Hello, I'm Hyewon from JUNGHWAN University. I'll present our work in progress study on griefing recognition via anomaly behavior detection. Have you ever encountered a troller before? If you're a game player, I'm pretty sure you have. Trolling is a problem that has to be addressed because it hurts other users' experience by lowering self esteem and often triggering retaliatory trolling. It comes in many forms, and we focus on griefing, which involves deliberately disrupting gameplay to harass and ruin others' experience. Other forms include flaming and lack of skill. So, our objective is to detect griefing behavior through deep learning by leveraging in game data and game design features. We collected data from an FPS shooting game called PUBG Battleground. Through its API, we were able to collect telemetry data of 26,807 match records. We transformed the data into a frequency-based action count vector and filtered it out so that only data for matches where team kills happened would be left. Griefing behavior can look different depending on the game, so we had to define what it looks like in PUBG. We interviewed two PUBG experts to identify common griefing behaviors and set guidelines to tell the difference between intentional and unintentional griefing. Based on the interview insights, we selected key features as such. Next, I'll talk about how we built our model. The data we collected were unlabeled, so we used a semi-supervised anomaly detection model called deviation network. Accordingly, we applied a semi-labeling process. Based on the interview insights, we created a matrix using the ratio of team attack counts to vehicle co-ride frequency. Since our dataset was built from matches that included at least one case of team killing, we only collected squad mode data. We started by provisionally labeling the top 25% of players as griefers. DevNet calculates an anomaly score for the entire dataset using partially labeled data. If the anomaly score is greater than the threshold, the user is considered anomalous. In the figure, you can see that there was a sharp increase in the anomaly score at the 87.5th percentile. Accordingly, the threshold for anomaly detection was set to 0.2. 71.75% of users in the test set had a DevNet score exceeding the threshold, which meant that our test set accuracy was approximately 72%. Current limitations include a focus on simple action frequency and a lack of temporal behavioral understanding. Also, since our dataset is FPS specific, generalizing to other genres would require custom behavior indicators and model adjustments. Thank you for listening. We're excited about the potential of our research to contribute to a fairer and a more enjoyable online gaming environment.